And I want to have a conversation with you all today about the social implications of bias in machine learning. Now, I realize there's a couple of terms in there that we might not all be on the same page on, so I want to quickly define those up front, starting with bias. So if we take some examples from the world, we can see some examples of bias that'll help us with this definition. So I won, so gambling must have been a good idea. So this is outcome bias, and this could lead to poverty in this case. There's a large man walking at night, he must be dangerous. This is stereotyping, and it could cause fractioning in society. We have another, people say that mobile phones cause cancer, so they must. This is the bandwagon effect, and it can lead to poor decision making. So these are some examples of bias where we could have negative impacts in society, but I want to be really clear that I'm talking here about social bias, and I'm not talking about statistical bias. Now, the reason I make this distinction is because we read a lot about statistical bias when we read about machine learning or statistics. It's commonplace. I just want to express that that's not what I'm going to discuss. What I'm talking about is social bias, and by that I mean prejudice, whether that's a conscious or an unconscious prejudice. It's just some kind of negative thought process about a particular group based on some protected attribute like race or gender or age. The thing that I'm not talking about, statistical bias, I will also quickly define. So this is when we need some measurement of something. So what we do is we take a bunch of measurements of that thing, average them out, and then the difference between that average and the actual thing we were measuring, that's statistical bias, but you don't have to worry about that because I'm not going to talk about it, which is lovely because it means we get to have a conversation about the human condition rather than hear about more maths. Now, I'm not saying that bias is something we need to completely eliminate and that it's evil. It's very much needed for us to get through our everyday lives because there's just so much information and we need to make decisions. Sometimes we have to take shortcuts and make assumptions. The only time that this is problematic is if those shortcuts are leading us in a direction that we don't want to be led, if they are making us oversimplify things and make assumptions about society that are damaging. The other thing I need to define here is machine learning. Just to help me understand, who here in the room is currently working with ML in some way? Awesome, we've got some people. Also, another question, who in the room already feels like they understand what machine learning is and they don't need an explanation? Cool, I really like that some of the people who raised their hand the first time didn't raise it the second time. That's honesty, I love it. So, for everyone who didn't raise their hand, what I'm talking about when I say machine learning in the context of this talk is I'm talking about algorithms and statistical models. Now, I'm going to use these words interchangeably in this context, and specifically I'm talking about computer systems that perform a specific task. So I'm not talking about generalized AI here. And I'm talking about them performing that specific task without implicit instruction. So not just a bunch of if-else statements dressed up as ML, but actually something based on inferences. So if we're comfortable with this definition, I'll give an example. So for ML, we have this ingredients list. First, we have some kind of question that we want to answer. Then we have some data that pertains to that question. We take a big chunk of that data and create a model. I know I'm oversimplifying so far, but I'll get into details later. And then to test that, we take the rest of the data and see if we get the answer we expected to that question. So for one example here, we might have the question, how likely is it that we're going to hire this candidate? And the data we might want is, what was our past hiring and the resumes maybe of those people? Then we want to know what's the correlation between those things so that we can make some kind of algorithm, and based on who was hired, we can see if that algorithm works. So a slightly more interesting example with image recognition. These are pictures of cats that I took. And to find them for this talk, I was just looking through my Google Photos library, thinking about experiences I'd had with cats. Like, usually they're inside, quite fluffy, 4 legs and a tail, that kind of thing. And it was getting really tedious and I was bored, so I just wrote cats into the search bar. Much easier. These popped up. But how did Google work out that they were pictures of cats? Because it can't do the same thing I was doing and think about the previous times that algorithm interacted with cats. So it has to have some other way of turning this 2D array of pixels into cat. So I don't know, but I imagine it's something like this. There's a bunch of labeled pictures that are labeled cat, and there's a bunch of pictures of not cats, and they all get fed into an algorithm. And in the end, we have some kind of formula for, is this a cat or not? But what's exciting about this is that if I went to somebody on the team who developed this, I'm positive they wouldn't be able to tell me, in that third layer of processing, the second pixel from the bottom on the left, what does that have as an impact on whether or not this is a picture of a cat? They probably have no idea. But this is the strength of ML. It's the fact that we can end up with some kind of algorithm we couldn't have imagined, something more powerful and complex than what we would have ourselves written, and that we might not even understand, but that it works. And it's this black box that I also want to focus on a bit later on. So it's not quite as simple as this implies, but there is some kind of trade-off between how observable or how much can I understand this algorithm and how complex, and usually complexity leads to accuracy, and accurate is it? And so between these two, we kind of have to make a decision. But hopefully it's not this simple. Now, how's this talk going to go down? I'd like to take you on a journey through from data collection and the way that data is processed, to the generation of a model, some observability, all the way through to how a product is used and governed. That's quite a lot of things. And for each of those, I want to give real examples. I want to say some of the risks that exist for society and suggest some tools that we can use that might help us. I'm going to mention a lot of tools, and I'm going to mention a few examples of the world. So at the very end, on the last slide, there will be a URL to see all of my references. So if you want to wait till then and take a photo, then you'll have all of that available to you as well. So let's get started. So starting, as everything does, with the collection of data. Now, I know most of us have, back at the office, a whole lake full of data that we could just start using. But I want to suggest that we shouldn't do that. Because that data that we already have, it might be vast and impressive and cool, but we don't really know which question did we have in mind when we collected it. And to give an example, I want to talk about Boston. So the city of Boston had this problem where there were a lot of potholes. And they wanted to prioritize which potholes should we fix, which ones are really impacting people. So what they did, like any modern city, they built an app. Great. So the app, you put it in the passenger seat of your car, and it uses the accelerometer inside the phone and also the GPS to work out, did you get interrupted by a pothole, and where were you when that happened? And this was excellent. They got all of this data about potholes and how impactful they were. And they noticed something a bit strange when they analyzed the data. It seemed like most of the really bad potholes existed in extremely wealthy suburbs, which seemed a bit odd. So they started putting this same app on phones on public buses and on garbage trucks. Suddenly, all these other potholes were showing up. And it was because of the way that this data was being collected. It was only wealthy people who had their own private vehicle with a spare seat, with a phone that was modern, with lots of battery, who valued this kind of public data collection, who were actually getting the data for them. And I think this really shows that the data doesn't speak for itself as much as we like to claim. It really does echo its creators, or the people who measured it, the collectors of that data. Another example of this is if I were to ask you about your earnings, and I did so as the tax office, or I did so as someone you're on a second date with, or I did so as a friend of yours who's going through some financial hardship. You might paint a slightly different picture of what those earnings are based on which of those three people I am when I ask you that question. Another quote I really like about this, saying that data being raw is both an oxymoron and a bad idea, but instead we need to cook it with care. So if we know that the time and the way we ask the question and how we measure data has such a big impact, then we really need to be intentional about how we go about doing it. And this is why I suggest that whatever data we have lying around might not be appropriate. There's a common thing that people say in ML, if you have garbage in, you get garbage out. I would extend this to, if you have bias in, you're going to get bias out as well. So one tool that I like for this is the Open Data Institute's Data Ethics Canvas. Each of these circles has a bunch of questions, which you probably can't read now, but you can look them up. And they ask questions pertaining to this. So some that I really like is it possible that this would have negative impacts on people? Could it cause harm? Could it be used to target, to profile, or to prejudice? Could it unfairly restrict access? Or could it be seen to be doing any of these things? Because perception is often reality. Another one is minimizing negative impact. So this one talks about what are the steps we could do to limit, to reduce the limitations of our data sources? And how can we measure the impact of the tools we're building so that we can pivot if we need to? So to summarize just this small section, all data is going to be biased, so we need to be careful about how we collect it. This is why we have to be skeptical of existing data that we already have. And a couple of tools. Another one is Ethical OS. They have a similar set of questions that are useful for this. So once we've got a bunch of data, we should just go ahead, right? I would suggest stopping at that point again and reflecting on what we've collected, because sometimes it's when we remove some information that we actually get better results. This might sound crazy, because if we have less data, surely we have less accuracy. If we measured those things, they must be real, they existed. But I'd like to question that. Let me share another story about orchestras. So historically, it was mostly men who had access to education and had leisure time to learn instruments. So of course, orchestras were mostly guys. Makes perfect sense. But as that started to change, and more people of any gender had access to learn instruments and be good at them, for some reason, audition-only orchestras didn't seem to represent the musicians of the world. And people wondered, why is this? And so what one group did was they put this curtain up whenever they were doing auditions, so that the people who were judging the musician couldn't see the gender of that person. And they thought, this will help. But it didn't. The difference in the gender parity was almost the same, until they asked the people to take off their shoes before they performed. Because it was the clippity-clappity, clippity-clappity of the heels walking across the stage that had already put in the back of the minds of the people who were making that decision the information about the gender of the person they were about to hear. And then suddenly, when the shoes were removed, women could play instruments. It was amazing. And then finally, they were getting the appropriate musician for the job, the person who could make the better sound with their instrument. So sometimes removing data, in this case the visual and part of the audio, was able to lead to a better, more accurate result. An example from my home country of Australia, there has been a law which has been in place since before I was born, which says all of these protected attributes cannot be used in any hiring decision. They say they can't legally use these reasons to hire, fire, or promote anyone. And many EU countries, including Germany, where I now live, also have similar laws to this. What's really beautiful about using ML for decision-making is that we can actually control exactly which bits of information we allow to be used to create our algorithms. It's really hard for people to do this, but machines can forget. If you don't tell them things to begin with, they don't know. It's beautiful. So sometimes we have to let that stuff go. Even though it feels more impressive to have more data and it feels more accurate, maybe it's actually not going to lead to the best outcomes. So there are some legal constraints on which data we are allowed to use for certain decisions. Sometimes reducing that data can increase the accuracy of our result. And forgetting is hard for us, but for machines, it's really easy. sometimes too easy. So to complete our 3-part series on data, I want to talk about the addition of missing data. This also might at first sound a little strange, because if we measured something carefully and we didn't see something in our data, why would we then need to add it? Surely it doesn't exist and therefore isn't real. Okay. But if we are making some kind of prediction about the future, usually that's the goal of these algorithms, right? We want to be able to project something that is going to be the case now or into the future. Then we can't only use the data we had in the past. We need to understand the trends, and we need to predict what is actually likely to happen next. So I think raising machines is similar to raising children. If you had a child and they were sick, you probably wouldn't these days say, let's go to the doctor and see what he thinks. Unless maybe this was a specific male doctor, you would probably say, let's go to the doctor and see what they think. Because you don't want your daughter to imagine she couldn't one day be the doctor. And also you don't want the awkward situation when you arrive at the doctor's and they don't use he, him, his. So in the same way, we can consider this for our models. One example with Google Translate, and this is my avatar at the top. This is me using Google Translate, and you can play along if you like. What I've done is I've picked Malay, and the reason I chose it is because Malay has this really cool gender-neutral they are, and it doesn't mean they as in a group of people, it's they as in one person. And so I wrote some Malay. I said they are a doctor, they are whatever, several things. And then we can guess by its inclusion in this talk what these might translate to. But if anyone wants to have some guesses, open to hearing them. James is not allowed to guess because he's seen my talk. Well, I'll show. So we end up exactly with he is a doctor, she is a nurse, etc. And I find this really predictable. I can imagine why this might be the case. Because if I was the person who was asked to develop this algorithm, I think I would get the same result the first time I did it. Because I would get all of the data that I have, all of the things that are in both Malay and in English, and I would feed them into an algorithm. And this is totally what I would get. Because historically there have been so many more instances of him being a doctor and her being a nurse. So why on earth wouldn't I get this? But really the problem here is that these outputs are based on historical patterns that we are not looking to reinforce. And these patterns aren't even true anymore. What I really like is that Google realized this and they did something about it. So though you can still see this when you translate in Malay, now when you use Turkish, which also has a singular they are, you get this. Now you see that she could be a doctor or he could be a doctor. And they've even said that they have a plan next to extend this beyond the gender binary. This is awesome. And it makes sense because this is actually the gender parity that we are getting for doctors. So it was inaccurate. It wasn't just inaccurate as a translation, but it was also inaccurate as a reflection of society. I'd like to introduce you to someone now called Joy, and she started this thing called the Algorithmic Justice League. So Joy, she's a researcher with MIT Media Lab, and for her master's thesis, what she studied was facial recognition software. And in particular, she focused on its accuracy for different groups based on gender and race. And what she found was that for women of color in particular, facial recognition software was nowhere near as accurate. The reason she even thought to study this in the first place was because she was doing an art project using facial recognition software. And I would like to share with you her experiences.
The system I was using worked well on my lighter-skinned friend's face, but when it came to detecting my face, it didn't do so well, until I put on a white mask.
I think this is a great example of a system that's not fit for purpose because of missing data. So this is a facial recognition piece of software, and that was a face, and it couldn't recognize it. And I think it's pretty clear the reason for that is likely that it didn't see enough faces like Joy's when it was being trained. One of the things that Joy really suggests in her advocacy work on this topic is that diversity in teams is a really huge bonus for trying to find who are the people missing from your data set. There's plenty of reasons why diversity in teams is good. We already have research that shows it helps with things like decision making and how much money a company makes. But if we needed another reason, here's another. Another way to maybe, if we can't have diversity in the teams we're in, another way to consider the other people who we might be missing is the tarot cards of tech. So this tool made it onto the technology radar released by ThoughtWorks. I think it was the second to last one. And I in particular want to point out this card, the Forgotten, because I think it's super relevant here. So it asks us to picture our user base and who might be excluded. One question I particularly like is, who is likely to give this product a 1-star review? And what would they write in the description? I think if we can think about that before we release something, maybe we won't get that 1-star review in the first place. Another tool for this is Google's PAIR initiative, their People plus AI research group, have something called Facets and another product called Facets Dive. So you don't have to read all of the information here, but this is the UCI census income dataset. And I've just got here a particular section highlighted. This is the group who are most represented in that census income dataset, which is awesome. If we want to write some algorithm that makes generalizations about this group, it's probably going to be extremely accurate, and that's great. But if we wanted to generalize this to a bigger group that didn't just include those people, to read it out, it's professional white married men, then we can see on the right-hand side, most of the other groups are really underrepresented. And this tool is great for pointing out who are those people who aren't seen in the data. Where do we need to collect more in order to have something that represents the group that we want to talk about? So to summarize this, sometimes our products aren't fit for purpose if we don't add the data that's missing. Diversity in teams, or at least diversity in who we consider to be our user base, or those impacted by our products, can help us here. And a couple of products, including Google PAIR's free tool, are really useful for this as well. Okay, so once the data seems in a good state, and we've trained some kind of model, wouldn't it be nice to understand really how it works? Next, I want to come to observability and justification, why this might be necessary, and how we might go about doing it. So recently, not that recently anymore, the GDPR came out, and something that I found particularly exciting about this piece of legislation was that it had a section which is being called the right to an explanation, and this applies to ML. I'm going to show you a bit of that now. So what it talks about is that the data subject, which in many cases is us, has the right to know about automated decision making that is being made about them. But they don't just have the right to know it's happening, they also have the right to have meaningful information about the logic involved. Doesn't this mean we have to open the black box? If we need to explain to users how that logic works, then we ourselves also need to understand it. The next point it says is they also need some idea about the envisioned consequences of that decision. I like this as well because it encourages teams to have to think about the envisioned consequences. So we need some way to open the black box, which I realize I had previously alluded to as being difficult or maybe impossible. But I don't want us to just do this because it was legislated. I think we want to do this anyway, even if the GDPR doesn't apply to us for some reason. Because I'm sure we've all been in this situation. There's a bug, right? And we've fixed it, but we didn't really understand why was there a bug in the first place. We're not exactly sure about what the thing was in our fix that made it work, but it seems to work now, so I'm sure it's fine. When you fix a bug in this way, you expect to see it again. So if we don't really understand why our models seem to test so well, they might not test well for the right reasons. So this is where Lime comes in. Now, Lime is a research paper and also a Python library, as is often the case. And You can pip install this if pip installing stuff is what you like, but I realize a lot of people here are in the Java world. There's some more examples later that might be more applicable to you. But what does this stand for? What is LIME? It's the local interpretable model-agnostic explanations. Whew, that's a mouthful. Let me try from the bottom up. So explanations. It's meant to give us a reason. Why does the model work this way? Model-agnostic. Doesn't matter what your model type is. Are you doing some kind of random forest? Are you doing a SVM? Are you doing neural networks? Doesn't matter. This will work. Then we've got interpretable, as in the people can actually understand what's going on, and local, as in local to the point where the decision was made. It probably still doesn't make sense. Let me use the example that LIME themselves use. This is a picture of a tree frog, or it has a p-value of 0.54 that it's a tree frog, but probably. But why? Why did the algorithm say that this was a tree frog? We can make some guesses, but if we had LIME, we could generate hundreds and thousands of versions of this picture, but with just some of the pixels turned off. And then we put those images through the algorithm and find out which ones of those are likely to be a tree frog. And this gives us some insight into what it was about this picture that made us say it was a tree frog. And we can see exactly which part it was that gave that result. And this doesn't just work for pictures, because you could have a data set and just remove some of the values from that data set and see if it's any more or less likely to get the same result. So this is hugely powerful. If that's too much Python, there's also Google, which have this what if tool. I feel like it's necessary at this point to say I'm not sponsored by Google. And this tool is also really useful, but not quite as strong, and it doesn't require any programming. So one thing I find really exciting about this is when humans make decisions, we often don't know why they made them. Even when we ourselves make a decision, we are so good at post hoc justification and lying to ourselves that we don't necessarily know why we made that choice. But if we let machines make decisions and we observe them using tools like this, then we might actually be able to know why the decision was made. And only then can we really interrogate that choice and see if it made sense and was fair. So in order to trust our own systems, we really need to know why they work the way they work. LIME can help us to open the black box, and other tools. There's also one by IBM in their Fairness 360 framework that has an implementation of LIME and a few other different ones. I briefly want to touch upon feedback loops. So a feedback loop would be when whatever the algorithm says the answer is gets turned into a decision, and that impacts the world. And then we again measure the world to get data for our next model. So we get this kind of loop. Maybe an example will help. So Facebook came under fire for so many things, but one of the things was the way that they were showing ads. So they have this famous ad platform. People upload an ad, it gets shown to a group of people, and then they get to see who actually saw my ad. Not specifically, but what were the demographics of the people who saw my ad. And Facebook boasts this great algorithm that shows people who are more receptive to the ad. Great. But what people noticed was if they put up ads for cleaning or secretarial work, even when they didn't specify a demographic, they were much more likely to show this ad to a lot more women. And if they showed an ad for a very high-paid job, they were much less likely to show this ad to people of color. So of course they came under fire for this. And I think the reason is because it helps with these feedback loops. If we have data that says these are the people who do this job, and then we generate a model based on that, and that gives us the decision to show people like that the job ad, then we're going to end up with the outcome of those people being in the interview. Those people getting hired for the work, and that feeds right back into our data again, and it's just a vicious cycle. So really, if we don't remove the bias, we're just automating it, which just increases its scope. I mean, if we have one person who's in recruitment who's a little bit biased, it has this much impact. But when we have an algorithm with it, it's this much impact. And this also happens in predictive policing and also in sentencing across the US. If we have predictive policing, that has these kinds of biases, the more you look, the more you find. So it can be really problematic. There's a tool called Compass that is still in use somehow in the US that ProPublica did an assessment of, and they found these results. So here are the two failure cases for a sentencing tool. We will have somebody was labeled as high risk of reoffending, but actually didn't reoffend, or they were labeled as not very likely to reoffend, but then they reoffended. So these are the two things that we would be trying to reduce the amount of when we're sort of tweaking our model when we're building it. And what they found was that for white people, they were much more likely to end up in this second category. They're not going to total 100 because these are only the failure cases, but they were much more likely to be considered low risk of reoffending, but actually reoffend. And the shocking bit, if it can be shocking anymore, is that it was flipped for African Americans. So we can see a really clear bias here in this algorithm, and yet it's still somehow in use. Yeah, I think that's how you reinforce stereotypes and discrimination. So I try to find a silver lining here, and I mean, we know that juries also fail, and we know that sometimes judges have biases too. So at least maybe if we have something that we can measure, something that we can actually see into, if we do this properly, then maybe we can end up with something more observable, and therefore maybe we can look at these differences and actually have something to look at there. But I'm really not seeing that right now. So today's outputs are tomorrow's inputs, and we need to think about which things we want to reinforce. Could we not reinforce the opposite and end up really helping to escalate a positive change? Lastly, I want to talk about usage of these tools and also the governance of them. Now, everything seems like it's just pretty code and it doesn't impact anything until it finally becomes a product and suddenly it's in the world changing people's lives. And that's what I want to touch upon. So there was a lot of really clickbaity titles of news articles, like last year, about Amazon's facial recognition software, because it managed to link 28 members of the US Congress to mugshots of criminals. And a spokesperson from Amazon, of course, came back with a response about this, and they said that this was an unacceptable test because it was using the 80% confidence threshold that is the default. And that's not fair. You should use a much higher confidence level when you're comparing mugshots, right? But actually, Amazon do sell this to law enforcement, and if that 80% is the default, is that not really asking for this problem to occur? So fortunately, some jurisdictions decided to ban this tool and ban facial recognition for this overall. And Microsoft begged to be regulated. I mean, when an industry or a company asks you to regulate it, you know there is something wrong. So this asks a good question. Is it the job of regulation to solve this? Should jurisdictions be banning this technology? Is it us as technologists? Do we need to sign some kind of oath and agree not to do evil things? Is it users? Do they need to demand better products? Do we need to rely on the media, ProPublica, to find out when something has gone wrong? Whose responsibility is this? I don't know. I think we can learn from other industries. One example is pharmaceuticals, as crazy as it sounds. But when I buy something off the shelf in a pharmacy, I find out what are the capabilities and limitations of this product. I know the active ingredient, what's the magic sauce that makes it work. They tell me this. They also tell me when and how to use it and when not to use it. They have some safety measures like this cool cap to avoid children from overdosing. And they recall their products if they find them to be dangerous. I think we can learn from all of these things in most tech products, but especially in ML. Because people forget that this stuff is just designed by humans, and we're fallible. As much as machines seem perfectly logical, they're still programmed by people, and people can still make mistakes. One example of this that I really liked was OpenAI. So OpenAI, as the name might imply, they do AI stuff and then they open it. So what they did recently was they did some AI stuff, but they didn't open it. And the reason was because what they had discovered was a way to make really believable text that read just like it was written by a human. And that's exciting. And they'd spent a lot of money and time on it, and they were really proud. But they thought about it a little bit before they put it out into the world. And they realized that, especially when combined with something like deep fakes, where you can generate pictures of believable people, would stop us from being able to know what was real in the world anymore. And that was really dangerous. So instead of releasing it, they made a cut-down version, they released that, and they opened a discussion about this problem. And I think that's brilliant. I would much rather be known as the person who didn't release the harmful thing. And that's what they are right now. Another thing I think we have to our advantage is the ability to update so quickly. I mean, in the pharmaceutical industry, when they find out that a drug is harmful, they have to try and communicate with everyone and get the drugs back because they're bad. But with us, we can just push an update. We can quickly fix or quickly recall a product, which no other industry has. If I want to make some kind of change in the world, one option is I can push out a person, raise them to be great, and then release them into society. But if I just want to make a change through code, I can simply git push, hopefully I have good CI/CD, and suddenly it's released into production. So we can use this to our advantage. So how can we inform, warn, and restrict our users through things like sensible defaults and being honest about the capabilities of our products? Can we demand better products, not just as users, but as technologists? We can make that demand. And unlike humans, we can quickly update or recall things. Better still, not release the dangerous things to begin with. So to summarize everything that I've said today, data is not lacking in bias from the beginning. It really does echo its creators. So we don't want to only find the potholes in rich suburbs. We need to very carefully collect this data and not just rely on what we already have. We can control exactly what information our algorithm uses to learn. How can we close the curtain and take off the shoes in other contexts beyond just musicians? Diversity in teams didn't really need another reason why it's a good idea, but maybe it can also help us to recognize Joy's face, to realize that not only he is a doctor. Can we use Lime to open the black box? Then we actually know how our systems work, and we can see if there are problems. Let's be aware of the reinforcing cycles that are bound to exist and make sure that we're reinforcing the things that we want to reinforce in the world. And how can we learn from other industries to set sensible defaults, to not release things that might be dangerous, and to recall them when they're found to be? I realize that everyone here in the room is a technologist, and that we all have a huge ability to make a massive impact on the world. What I really hope now is that we have an idea about how to make that impact a little bit more positive. I'm happy to take questions here or to take questions later, one-on-one. Thank you. And that's the URL that I mentioned with all my references. A microphone is being prepared. There's already one question. There's already two questions. Excellent.
Okay, Fiona, thanks for a great talk. My question is, why is it important that we should consider bias? Why does it matter? If bias exists in machine learning, doesn't that just mean that things exist the way they are, or does it mean that we should fight it?
Well, I would definitely suggest that we should fight it, but my standard response to most things is a revolution, so that might be my own bias. It really depends on what kind of world we all want to live in 20, 30, 40 years. And if we're happy for one to exist that more reflects what happened many, many years ago, or if we want to continue to reinforce the trends that we're seeing. So I personally want to see improvement continue, and I think we need to be a part of that. Thanks for your question, James.
Hi, my name is Arsen. Thanks for bringing an important topic up and like a really tough discussion. So, question I have for myself included is like, one of the most popular ways of collecting the data is this flywheel where you feed some results of your machine learning into like people, and they help you retag what wasn't tagged, and then it goes back into your input. So humans are essentially part of data collection. You cannot abstract them away. And as you mentioned, bias is fundamental to human existence. Now, this means that I'm not sure if there is a way, and that's probably the question. Is there a way to decouple these two? And if not, how do you deal with that afterwards?
Let me see if I've understood the question. So are we talking about how in the data collection humans are involved, and therefore it's difficult to avoid bias that would be introduced by those humans? Or have I misunderstood?
Yeah, so I'll use an example. One of those is, let's say Google Photos. Whenever Google fails to detect a photo, they come back to you saying, you know, here's the picture, is that really James? Is that really ours? And whatever. And you say, yes, no, and that kind of helps them build this. So essentially, this way of collecting data is very popular because A, you get free labor, you get free tagging, and most of the machine learning algorithms are supervised right now, so it kind of builds this whole ecosystem. Now, it's not just Google. There are other places where you have human annotators, which brings us back. So essentially, we're talking not just about removing it from the algorithm, we're talking about removing it from humans. Now, there is a chicken and egg problem, right? That's the question.
Thank you so much for this question. I think one approach that I couldn't recommend here would be the diversity of the people doing the labeling, because I know that there were some problems, especially with Google's algorithms, where they would see a bride in like a traditional Western bride, and it would say bride or wedding or whatever, and then they would see, for instance, an Indian woman dressed in traditional bridal wear, and it would say something like costume. And this is partly because of the people, I would imagine, partly because of the people doing the labeling, like you were saying. And I think if this was a more diverse group, that could also help. But I think you're right, that it is a huge issue and maybe really hard to decouple. This is my only thinking off the top of my head.
When somebody like OpenAI discovers something dangerous, and they've built something dangerous, and then they just say, you know what, we're going to lock it up. Are they not, should they not be releasing it in some controlled way for somebody to design a countermeasure? Because if somebody is designing a weapon of mass destruction, but they just say, oh, we found this very dangerous thing, but we've locked it up so you don't have to worry, but somebody else is going to find it. So
yeah.
Is there a procedure? Does OpenAI have that? Because otherwise I'm sort of losing respect for that whole process.
Yeah, I think it's a great point. There is a risk, especially now that people know it's possible, though some people are skeptical that they actually have an algorithm. But now that we know it's possible to do it, someone else, as you said, could do the same thing, and then they could release it without thinking. And I think this is why they released a smaller cut-down version and why they tried to start this conversation. So I think the hope, I'm assuming, would be that people start to work on measures for when this does eventually come up, because everything that can be discovered will one day be discovered. Yeah, really good point. Thanks for bringing it up. We have one more at the front, if we've got time. Yeah. This gentleman here. Thanks.
Just this orchestra question. Do you have any idea why the males prefer males? So I really don't understand this. It would be like a natural behavior of males to prefer a female colleague in the team.
Interesting question. So about the orchestras, this was asking why it would be that the assumedly male judges would pick a male over a female. I think the reason for this was this weird connotation between men and the ability to play instruments that came from the historical times where that was the only case. I think we can see similar things in computer science. People just imagine this man when they think of a hacker or a computer programmer, and this can bias us to prefer to hire a man, even if we actually would love to work with women. So I think it's that, but of course, I'm not a psychologist, so I can only guess. But thanks for your question. I'm happy to take more questions one-on-one and have a discussion about this. I'd be in particular interested in hearing people's thoughts on how this should be governed and whose responsibility it is. So thank you so much for listening.